Hi everyone. So I would like to welcome everyone to our platform of Educator's Mind, which is an online tutoring platform for students, those who are preparing for IIT, JEE and NEET. Okay, and also those students who are attending class 11 or class 12. So we are starting this introductory class right from class 11. So as you will see in today's session, we are going to give an introduction of physics, which is particularly useful for those students who are coming in class 11 from class 10th. Okay, as the session starts, you will be seeing that people particularly coming from class 10th, okay, they will face lot of problems generally, right? Because as you come in physics, lot of symbols are coming into picture. As soon as you open the physics book and CRT, all the statements written and delta and phi, psi, so many symbols are coming, and sometimes you may get confused, what is this? Okay, and people develop, right, fear, little bit fear about physics. What is this? Okay, I don't know this, and some kind of that comes a feeling, because of which they feel a hindrance, there is a resistance to accept new things. So we want to address this point, because once you become comfortable with that, then you will develop an interest for learning on your own. And the first thing to develop an interest is to raise questions. Without question, okay, first of all asking question, raising question in mind, okay, and then trying to find the answer of those questions. In that way science develops, and that way research happens, or anything. So first you have to ask question. You are not satisfied with whatever the things is presented to you. Suppose I give you something to eat, you are not satisfied. I want that, I want that, I want this, I want. This is what is inquisitiveness. So similarly here, of course, not about eating. We are talking about knowledge. So you are not satisfied with a particular thing, and you want to explore more and more. So you want to go further and ask question. Okay. So that way your learning will develop. So first question is to be inquisitive, to ask questions, and then also take those questions seriously, not that just ask and leave it. Okay, just you ask to your friends and he will search the answers. No, you have to search the answer. There are so many sources of knowledge, right? You can ask your teachers, your parents, your friends, discuss among themselves and try to gain knowledge. So physics is all about knowledge. So let us understand what do we study in physics, what is the introduction. Okay, what is physics, how do we study in physics, and why we study physics. That is also very important. Why do you study physics as an individual subject? When you were in class 9, 10, you are studying all subjects together. Why do you want to take this particular subject and all this particular subject, biology, chemistry, physics? Why not keep everything together? Because as you know, science develops, the things also increases, the knowledge of human increases, or it expands, and people start finding out that a particular kind of knowledge is used for developing a particular application. So based on the development of certain application, engineering application, technological application, you try to divide the knowledge into certain groups or categories. So these have been developed by human beings. They have categorized this branch of like science as physics, chemistry, and they have particular applications in human life. Okay, of course they also share common boundaries among themselves. Like for example, you know, in physics lot of application of mathematics is there. You will see lot of integration, differentiation, vector, binomial theorem, algebra, so many things will be coming into picture. So unless your mathematical background is good, you will find it difficult. So this is also important that at the same time while learning physics, you should try to build your mathematical foundation as well. Okay, so we will see that. Let's start the session. Okay, so what is physics? So first question is, we are going to understand what is physics. So we are starting with a question, you see, we are starting with it, and we'll try to find out the answer of that. So what is physics? Physics is nothing but it is the study of nature and its laws. So what we are going to study in physics, we are studying the nature and the laws of nature. How the nature is working according to some, according to some principles. Some principles it is working, some rules it is working. Rule of nature or the game of nature. Nature is working according to some principles or rules. So we want to understand that rule, we want to know even to the extent of modifying that. That is also sometimes the higher goal of science, which may not be correct. You can justify it, but you cannot control the nature. If you try to control nature, then we do not know what will happen. So certainly we should not try to play with the nature, rather we should try to learn from nature. We should try to learn from nature how nature is working and appreciate that. That is the goal of science as well as physics. So that is what I understand. Okay, so based on this, now physics is study of nature and also it is based on a scientific method. We do not study physics haphazardly. We study based on a scientific method. So what is that scientific method? Okay, not that anybody can study in any way. Yes, anybody can study, but you have to follow some rules and regulations, the disciplines. That's why it is called a discipline of science. Okay, and it involves the method, the scientific method involves some steps. What are those steps? Let us understand. And these steps are interconnected. This means don't think that you will go to third step and then fourth step or last step. No, you have to go first step, then second step, then third step, like a ladder. As you climb one ladder, then second, like that, one step, second step, like that it is. You cannot escape certain steps and then you say that, oh, I can understand physics or I can do this. No, you have to go step by step. So first step is systematic observation. So the observation is there. The first step is to observe things in nature. You have to be a keen observer of nature. So scientists like Newton, Galileo and many scientists, they have this quality, the quality of keen observer. Okay, they are keen observer of nature. They are always very much alert. Okay, what is happening in this system? Stone is falling, and then they will observe even a leaf is falling, fruit is falling, everything is falling. Then they will raise question, why this is falling, why not it is going in some other direction. Then based on the questions that comes in their mind, they try to develop some theories. Okay, so the first step is to systematic. What is called systematic observation? Observation is okay, I can understand. Observe things, anything we can observe with our eyes, or we can observe with a microscope, telescope. Okay, something which you cannot see with your eyes, you can observe. Okay, now systematic observation means systematically. This means you observe one time, you observe two times, you observe three times, so many times. Repeat your observation and see whether the same result you are getting or not. That is what is systematic. If every time different results are coming, this means you have to interpret the result in a different manner. You may have to change your vision, you may have to magnify your lenses. Maybe there is defect in your vision, defect in your instrument. Okay, why every time different result is coming? So there are some errors like that. So you need to try to reduce the errors then. That is what is called systematic observation. So you have to set up some rules to do that observation also. Next, second is the controlled experiments. What is called controlled experiment? Now suppose you have observed in nature certain phenomena, natural phenomena or events, you have observed it. Now you have seen that this is the thing happening. Now the question should be, is it happening everywhere? Suppose it is happening in India. Is it also happening in US? It is also happening in UK. Is it also happening anywhere on the part of the earth? Is it also happening everywhere in the universe? That's it. Or is it also going to happen in my laboratory? So I will test that. Okay. So let us do the experiments and see whether what I have observed is correct or not. Okay, so you will then be doing some experiments in your laboratory to see the results of a particular event. You will do, so let us say you drop a ball in your lab, or you go in an outside building, from building you drop, same effect would come. So then you are observing it properly. Okay, then in your lab you have to do controlled means you need to control the external factor, because sometimes you know, you are doing some experiment and somebody nearby, your friend is talking, then you get disturbed or somebody is calling you, some phone is ringing, so these things will distract you. So the scientists who do research, they remain also secluded, they remain in one sense isolated, for at least for doing the experimental work. They have to isolate, they have to prepare a lab. That's why we say that is a laboratory. You do experiments there, you don't do chit chatting there. Okay, you have to do the experiments there. So environment must be controlled, otherwise some external factor may affect your experiment and then you will get a different result. So your experiment is not correct, then your result will not be correct, error will be included in that. Okay, so that's why you have to choose a controlled atmosphere to carry out experimentations. Then qualitative, next step is qualitative and quantitative reasoning. Now once you do the experiment, you get some result, you have to qualitatively think. Suppose if I increase the input, then how the output is changing, is the output also increasing, is the output decreasing? So this kind of analysis where you are trying to predict the output will increase or output will decrease, that is called qualitative analysis or reasoning. And quantitative means how much it is increasing or how much it is decreasing. Okay, you may say 2 times, 3 times, 4 times, you are giving a number to that. Okay, so that will help you to develop proper understanding about the equations and the laws. So that is why the next step is to develop a mathematical model and use it for prediction. What is mathematical model? Now you know that two quantities are related, input and output is related like that. So what is the equation for that? Let us say force is equal to mass into acceleration. So force is related with mass and acceleration using this equation. Now if you increase the mass, keeping other thing constant, how the acceleration is changing if you change the force. Okay, if you apply a particular kind of force and if you change the mass keeping the acceleration same, then how things are changing. So there can be more than one factors involved in a equation. Okay, there can be external factors also. That's why you have to do controlled experiment, and these are the inputs you have to identify, and that is the output. Sometimes this is also called design of experiments, DOE. So those who are doing research, they first of all do DOE. What are the input parameters or variables and what is the output? Okay, so mathematical model is nothing but it is a mathematical equation which you develop by doing experiments and understanding that if I increase this input, output is getting affected in this manner, and then you make a equation. Okay, make an equation, and based on that equation, which is your model, that is your mathematical model, you try to predict the output. Suppose if I increase the mass also, I increase the acceleration also, I increase this thing, that thing, so how the force is changing, how the output is changing, that is called prediction. Now you have predicted your result based on your experiment, based on your theory. Also you have to, now next step is to validate or verify in nature whether the theory or the model which you have made is correct or not. This means you have made a formula, force is equal to, let us say, mass into acceleration. You need to also check in the outside nature, outside your laboratory, whether this is validating or not. You need to also check, this means you can do further experiments to see whether your law is correct or not. Okay, so if it is not correct, if it is error is coming, if there is a deviation, how much is deviation, how much is the percentage error? Okay, 10%, 20%, how much? 5%. If your error is generally within 15%, error is considered as a good theory or good model. okay, in experiment. If it is more than, that model is not means assumed or not considered as correct. Okay, so this is what is the introduction about physics. So hope you like this introduction, and then we will be going to the next. Also in the next class, one topic we will introduce in a means easily digestible manner, so that you can relate to it. Okay, we don't want to bombard you with knowledge, so gradually we will move forward. So if you like also, so you can comment. Okay, you can give question, whatever the questions we have. So let us connect. If you think that our classes are going to help you out in some manner, so why don't you connect with us? We will be very much happy to connect with you. So you can follow our link. We have our website, our Facebook link, our LinkedIn platform. We have Twitter platform and also on Instagram. So please follow up, please subscribe us. Okay, and if you like, you can share with your friends. Okay, so that everybody can connect with us. Okay, so thank you guys for your attention. So hope that you will enjoy our classes also future. Okay, thank you. Bye bye all.